Hello everyone! Today we're going to be talking about the conservation of energy in a very brief video. In this video we're talking about how energy gets redistributed but never is lost. So this is the concept of the conservation of energy. The question they pose to us here is, have you ever seen the aftermath of a vehicle collision? You may notice that parts of the car are crumpled or torn off, the glass is broken, and the fluids may be leaking from the engine. Of course, if you witnessed the actual collision, you would have heard sounds of the two cars colliding and possibly hitting other objects as well. All these observations are examples of the law of conservation of energy at work. So what they're talking about here is that the car initially has much of its energy stored in kinetic energy. It's moving, and the movement of that car, suddenly when the car collides with something, so in this example we have a lamppost, when that car collides with a lamppost, the energy, the energy that's allowing that car to move and allowing that car to travel is going to be converted into different types of energy, like sound energy. So the energy of moving air particles that hit your eardrums and let you hear the noise of the car screech and crash. It's also going to be converted into other types of kinetic energy. Movement of the crumple zones upon each other, compression of those crumple zones. Springs in the car will be compressed in a way of elastic energy. You'll see the actual structural energy that the chemical structures of the glass will break apart and they'll smash. All these sorts of things. These are all examples of energy being converted, but the energy is not lost. So the law of conservation of energy states that energy cannot be lost or created, but can only be transformed, so changing of types, or converted into different forms of energy. In addition to converting energy from one form to another, energy can also be transferred between two objects. So we can actually see some of that transfer in this little doodle here. You can see that the energy has been transferred into this pole, which has deformed the pole. It has changed the shape of the pole. So there was actually movement of energy from the car into the pole. If you have ever played hockey or a sport, you transfer energy from your body into the ball or into the puck in order to propel those objects forward. So there's a transfer of kinetic energy in that case. In a vehicle collision, energy is transferred from the car to the pavement, into specific areas of the car, and into the driver and passengers. For example, energy from movement of the car can be transferred to the bumpers, and the bumpers in most cars nowadays will crumple. This is known as a crumple zone, where the car is actually structurally less strong in certain areas, and those areas will collapse more readily, more easily, and will absorb energy, or energy can transfer to those zones more easily, removing the amount of energy that will transfer to the people inside. Now your bones and your body of the passengers, those also could absorb energy as it's being transferred around the car from the collision. So in a car collision, huge amounts of kinetic energy are converted and transferred in several different types of energy. These include the energy of motion. So this is one of the forms of kinetic energy, energy of motion. But the energy could also be stored electrically or chemically or in elastics and springs. So those are another type. If we think about springs, a spring, which is one of these kind of things, a spring has less energy versus when it is compressed up like so, then it has more energy. So that's energy of compression or elastic energy. Unrestrained passengers. So since energy cannot be destroyed, whenever kinetic energy is reduced to zero, so this means that when we say reduced to zero, that means that the car stops moving. Car stops moving. Then other forms of energy increase. This usually means other forms of kinetic energy increase in other places. So for example, less motion could mean more sound and heat. Sound and heat are the motion of particles and light and photons in the area. So the kinetic energy is transferred to other particles, and those particles are now moving. After a crash has taken place, the momentum of the car is reduced to zero. This means that there is no more kinetic energy. All the kinetic energy is transferred and converted to other forms and systems. This is dangerous for passengers, especially unrestrained ones, as they then become the moving objects in the car with great amounts of kinetic energy. This is where the second collision occurs and causes injury to the moving passengers. So the passengers in the car are now have energy transferred to them that causes them to continue to move. So let's talk about some energy transformations and some examples of energy transformation. So for example, a child on a pogo stick can be thought of as an energy transformation. The child has if you don't know what a pogo stick is, it's one of those, a stick like this. I don't think I've ever actually tried riding on one. And it has a spring on the bottom, like that. And then a child will stand on it, usually a child. I'm sure there are adults who still enjoy a good pogo sticking, but not myself. So the child stands on top of the pogo stick, and they have a little handlebar here that they hold on to, and they jump up in the air, and the way that they jump up is that they will there's sort of two different versions of this pogo stick. One where they're up in the air and the spring is extended, and then it compresses back down. So the spring gets compressed, so compressed, and then it is relaxed. And so when they're jumping in the air, so in the air, they have kinetic energy, and then on the land, on ground, the energy is converted to elastic energy in the spring. So they store up this energy inside of the spring when they land, and then when they jump into the air, what's happening is essentially that spring is contributing that stored energy to their movement so that they can fly high into the air. So we can think about a pole vaulter. So let's see if I can draw. I'm going to have to do a line drawing because I don't know if I can draw a pole vaulter very well otherwise, but I think I can get a pretty decent pole vaulter body position here. So a pole vaulter essentially sticks their pole in the ground, usually like this. There's a little clip here that they stick it into, and then they will swing up into the air. And so I'm going to put them here, and then we have this sort of part here where they are sort of hanging from the pole. I don't know if they hang quite in such a dramatic fashion, but they are accelerated by the bent spring. So again, this is sort of elastic energy. And if we put the pole vaulter over here too, we can see that they started their run with the pole straight. So they actually have kinetic energy here. And then when they're trying to jump over the loop, the person is also going to, you know, it looks something like that. And there's some feet. Okay, they are actually freely flying, so it's kinetic again. So let's see if I can explain that. So the pole vaulter runs, which is kinetic, and then bends the pole with their momentum, which is now elastic. And then as the pole bends, pole straightens, throwing the vaulter into the air, which is kinetic again. So in this way, they're able to essentially store their energy inside the bent pole. And this stored energy is a concept that's not mentioned here, oddly enough, but this stored energy is what is also known as a potential energy. So potential energy. And I think I might have to include another video on the differences between potential and kinetic energy, because I noticed that it's missing from this discussion right now, but I'm missing out on something that shows up later. So I'm just going to do a little brief definition here. So potential energy is stored energy. And versus kinetic energy, which is moving energy. And in most physics, we can divide all types of energy into these two types. Heat energy is the movement of air particles usually, or at least convection energy is movement of hot air in your home or in your house. That's kinetic. You have driving is a kinetic energy because your car is moving. But the chemicals that you use to power your car, this is a potential energy. And then that potential energy in that car's gasoline is burned, releasing it, converting it into kinetic heat energy. So, examples like heat and motion. But you also have stored energy, like in terms of gravitational energy, potential. So this is the energy if you just put an object on a table, potential. If you put an object on a table, then it has more energy than when it was on the ground. And if the table breaks, that object will fall and gain kinetic energy. So another one is elastic energy. That's also another example of a stored energy. And the final one we usually talk about is chemical. So chemicals have stored energy in them. Okay, so a car shoots through an intersection that you are approaching in your car. You brake hard to avoid the other car and leave skid marks on the road. You cannot avoid hitting the other car, and you hear a loud crash as you collide. Okay, so we have a lot of energy types here. We have the car is moving, so that would be just straight up kinetic energy. Boy, there's a word I'm looking for here that I'm just mechanical energy, right? So another word for this, kinetic energy, an object in motion. Object in motion is thought of as mechanical energy. Usually an object that has both a little bit of kinetic energy and a little bit of potential energy. So there's some mechanics involved, moving parts. the car is moving. Then when you brake, the brakes apply friction, and friction is an interaction. It's trying to slow the motion, and it's related to some sort of, well, I'm not sure, frictional energy. Let's just call it that, frictional energy. And then we see some heat. Heat is formed which melts the heat is formed. So there's some energy in heat. This melts the tires, right? Melts the tires a little bit, which leaves them in a new organization. This is kind of a change in the chemicals, even. And we could keep going. We even there's a loud crash. We have sound energy. Energy formed in the crash sound. In the crash. The crash sound. So, there's lots of different energy that's formed. All from a couple of cars that just had some basic mechanical energy, but then when they hit each other, we get all these different changes. There are springs that are affected. There are other things that happen. So in the next video, we'll talk about some effects of friction. And in the meantime, I will talk to you later.